Yeah, I was thinking about maybe talking about the UTXO model, unless you're super used to it.
Do that. Do that. Please, please,
Do-
please, please.
Okay.
Extended UTXO model, please.
No, it's not going to be the extended yet. Uh,
Ah,
well,
spoiler.
gotta
Sorry.
go.
Sorry, Kathy. That was a
Gotta go.
spoiler.
Gotta go step by step. I
Please do.
was, yeah, I was hoping to. Do you have a Cardano wallet?
Yeah.
You do. Okay.
I have
And
Whisper.
okay, yeah, that's good. Do you know how many keys you have inside that wallet? That's the
How
tricky
many
question.
keys?
How many keys?
No,
Well,
I don't think I do. I need to check. I think I have one key. I only set up one key
are you delegated to a stake pool?
to a D-rep.
Then you have more than one key.
Then I have more than one key.
Mhm.
Okay.
And a stake pool.
Did I delegate to a stake pool as well?
Yes, a la North Pole.
Oh,
Well,
yeah, I did. I'm
that
so glad you said, Kenny, because I can't remember. And I only
it's
did this weekend. No, last week, I think.
it's a great pool. It's a great pool. You did
Cool.
you took the right choice. But as you may know, delegating
It
to
wasn't what it, she didn't have a choice. I'm
I
sorry, I have
didn't
to
have
bring
a
that up.
oh,
choice.
okay. I don't know what kind of deal you guys have, but it's still a great pool for network security.
That's good.
I'm just kidding.
So as you may know, in the background of your wallet, let's phrase it like that. So in the back end, I'm gonna say it like this. You have two sets of keys. You have two set of key pairs in a way. Okay, you have the payment key pairs and you have the stake key pairs.
Okay.
The payment key pairs, and it's very similar than any other key pairs, right? You have the public key and the private key, or for Cardano, we call them the verification key and the signing key. But there's a private
Oh,
part and
okay.
a public one. And a
So
part,
that's the same as the public and the private key. The verification
yes,
key and the signing one is the same as the public and the.
same.
So, which one is the public and which one is
The
the private?
verification key for Cardano is the public one, and the signing key is the private one. So when you create a wallet, you also create a spending password, which is nothing else than just your private key being encrypted with a password. You derive those keys with the seed phrase, but once it's derived into an actual key pair, the private key is encrypted with your spending password. And every time you use it to sign a transaction, you have to type down the payment password in order to unencrypt it and sign your transaction with it. So if I go back to my terminal and I share it, there you go. We have, well, actually, I have two terminals, so I didn't know which one you would prefer. I got the local one and the server one. On the right side is the server, and on the left side is the local uh, environment. We could use both, doesn't matter. Um, yeah, so let's say I have a node in there, right? Let's presume I have a node. So I will just start it because I do have a node, systemctl, or start just in case. Uh, and it's a central node, so it's not
Okay.
anything related to the mainnet. It's just a testnet. Uh, let's create a directory, and we will call it um, Kathy Keys. Oh, wait, no. Yeah, make directory.
Make directory.
Just for the fun of it. Could you say generic, but that's already been done before. Uh, okay, let's. What? I'm trying to make this thing not boring. It's probably not. Okay,
I haven't been bored yet.
good.
I'll let you know if I get bored.
Mike, this is boring. That would be.
Then I'm gonna say, Mike, now you need to spice things up.
I need infographics. Actually, I do have an infographic. That's the nice part. I think I've showed you this one before, did I?
Yeah, I saw it, but just the overview. I haven't seen the details of
Yes.
it, but I think it's available, so I could study it. I think I have it
Yep.
open somewhere.
That's the version 8.22, which is very old, but as a matter of fact, all the commands are still the same ones. So there's not much change. We can still use it. I do still use it, actually. So let's go slowly but surely. I'll put that aside. I'll go to the tutorial and I will create some keys. So I'm in Catty keys. I have nothing in that file. So if you rely on the CLI, which I love and nobody else does, but
I do.
you do, awesome. So that makes us two.
Soon Catty too. She's gonna like CLI soon.
I have
Yeah,
no
then
choice.
the nice thing about the CLI is that you will always be in advance. So every tooling that you have right now, it's always derived from, other tools that serialize the transactions the same way we do with the CLI or an Haskell node. And as useful as it can be, it's always, not always, I can't say that, but it's very oftenly late. So we get a new node, we get new features. The CLI is always up to date because it releases the node with the CLI. You already have access to those features, but if you use other tools like Lucid, like other ways that serialize uh, the transactions in another way with another language, you might have to wait for those features to be available as soon as they update their repository. That being said, the Cardano CLI is always something you can rely on, and it always works.
Yes, and then it's CLI stands for Command Line Interface.
Oh, yes, command
Yeah.
line interface. Okay, so now I want to generate some Cardano keys. You can either, oh, and by the way, I had to download the binaries, right? So I'm assuming that we already have those binaries. I could show you later where to get them.
Yeah, would you?
Oh yeah, you wanna? Okay,
Because I
sure.
don't have them.
Yep. So it's either you compile it with Haskell, or if you trust IOG, which I do, you would just get the already compiled binaries. So I'll give you the hold on a second. I need yeah, I'll give you the link.
Great, that would be nice.
So it's on GitHub intersect MBO intersect
I
MBO.
was thinking I could do this chilling out in my couch, but I really need two screens to do this. I realize now too much things. I need two screens. I need to focus, and I need to take notes. This
Yes,
is just too interesting.
two screens is the bare minimum. Uh,
Absolutely.
Actually, I do have needs for more than two. I can
I
tell you.
guess you would.
Yes, I'm at five, and I got room for one more, but my never mind. Anyway,
And your
that's off
Oh,
graphics
topic.
by the way,
card
Mike,
can go
I
on
have
more.
to tell. By the way, Mike, I have to tell you something. I think you're gonna you're gonna be impressed. So, Kathy, she just got herself not a Ubiquiti, but she got military grade.
Apricorn, Apricorn. Did she?
Let me show her. You're gonna be impressed. I was impressed.
I can't see it. Of what is it?
This is a military grade YubiKey, Norwegian designed, military grade. Yeah, it's a FIDO YubiKey to keep
Wow.
your passwords. I asked my boyfriend, who is also IT boss, where I could get one of these, and he said he had one lying around. And it turns out I thought it was just a small YubiKey, but turns out that he had a military grade one. So I'm setting this up on the side. So I'm quite excited about that.
Nice.
Toys.
She just
Actually,
bought herself a cold storage and didn't know it.
well,
Yeah,
YubiKey support ED25519 keys, so there's a lot of stuff she could do with it, like
Yeah,
related
yeah,
to
yeah.
yeah, yeah.
Cardano. Oh my
I'm quite
God.
excited to do this, to set this up.
Yeah, yeah, you can do a lot with that. Oh yeah, especially with GPG. GPG. Okay. Yeah, we could use that too, right? Could be more related to security features. Do you have? No, I should not ask questions. It's a workshop. We need to
You
focus
can
on.
ask, but I'm not sure I can answer.
Okay, yeah, sorry, I derailed it. You don't need to make it
I
worse, Mike.
no, yeah, I had questions about entropy, but that's gonna be for later. It's going to be later. Yes, so okay, the node binaries. I'm gonna give you a link. Let's see the releases. I think they got the. Let me see the tags. All right, no, they're still at 10.5.1. Okay, I'll give you this link. So if where should I? I'll put it in the yeah, I'll put it in the chat of this meeting. So this is where you can get the binaries. Do I share my screen? I'm not sharing my screen. Hold on a second. Title screen, this one there. All right. So that's the link to the latest release of the Cardano node. And within those binaries, like if you get, like I'm going to get the Linux one because that's a Linux environment. So I'll just copy the link and I will put that there. Um, it's wget and get it. So you can get all the Cardano nodes binaries in the command line interface through that link, but you get it compressed, right? So you need to
Okay.
extract it. So I'll do tar xvf and then the compressed file, and it's going to extract it. All right, I got it. And now you get a share file with the configuration file of all networks. And well, we can just take a look. Do you want it bigger like this? Maybe, perhaps.
Yeah, that's nice.
Okay. And within that share, you have the configuration file for all the networks, including mainnet. But of course, CentralNet is not there anymore because I control it and IOG doesn't have control over it anymore. So if you want those config file, I can give you a hand with this, probably later. Uh, but right now, for what we do, that's not useful. All you need is within the bin file. And then you have all the binaries for whatever you need to do. You have the binaries for the Cardinal node. If you want to run the node, you have the binaries for the CLI, which is mainly what I'm going to use to generate your keys and create transactions, anything that doesn't necessarily need a node. Because you can technically with the CLI, you can build everything offline without a node. You can generate your keys, you can build a transaction, but at the end of the day, you will end up having to submit your transaction somehow with the blockchain, right? So you will need to interact with a node or an API or something that will submit the transaction for you on the whatever network you want to use.
You can write that down, the TX, on a piece of paper if you have a very, very good time.
What do you mean a piece of paper?
Yeah. So instead of extracting the file, you can just look at the screen and write down, on a piece of paper, a transaction.
Well, I don't think that's a good idea. It's going to take a while.
Yeah, just kidding.
But
You have too
anyway,
much time on your hands, Kinetic.
that being said, that binary that I just showed you, I just moved it to my user local bin, and I made it available from anywhere. So if I'm just, from my home environment, I do Cardano CLI, CLI dash dash version, for example, it's accessible from anywhere.
Oh, that's nice.
So that's what I did. You just get the binaries, you put them somewhere where your shell will find it, and then you can use it. Yeah, so clear. That sums what I did. So if we get back to Cathy's keys with a capital C, I don't know why I did that. Uh, I'll just remove everything because I don't need that anymore. RF bin and share. Let's make it clean. There. Okay. So now we have the Cardinal CLI. We are ready to build some keys. So if you look at the infographic here, you can see the tiny command over there. So if you look like this, um, uh, Cardinal CLI Conway address key gen. Okay. No, so you have to zoom.
Yeah, you have to zoom. That's like looking across the world. Thank
Slightly
you.
better, thank you.
So much better. I was like, how can you see that?
Right. Now, the reason why I zoomed out is because everything related to the CLI, I don't know if I repeat myself. Let me know if I do. Everything about the CLI has some specific rules. Okay. And the specific rules are explained at the bottom left of the infographic here. So there's a little tutorial on how to build a command with explanations and some arrows. Okay.
Do you have the infographic somewhere?
Yes.
I don't think I can find. I thought I had it because I was sure that you had linked it somewhere, but I can't find it.
I think it's in the documents of Discord, isn't it?
Yeah, probably.
It's also available on my repository. So if I'm going to give you,
I have the Cardano roadmap.
there it is. So if you click on the
Thank you.
link, that's my GitHub account. So you just go into the repository and you look for infographics.
Oh, great. Thank you.
So they're all there. You're going to want to look for Cardinal CLI, and it's called the Cardinal CLI cheat sheet version 22.0.0. But this one's in PDF. Strangely, it's in PDF. I don't know why I did that. Oh, right. The reason why I made it in PDF is because you can copy paste the command. So it's going to be like much easier for you to, instead of uh, manually typing them down, if it's a PNG, if it's in PNG format, you can use the PDF and select the text and copy paste it on your terminal or on your whatever you're using. Yeah, so it's there.
Cool.
Let's go back to the tutorial. There's also a CentralNet tutorial, which is very useful if you want to do different things like creating a wallet, stake pool, delegated representative, CC, build governance actions, all the things we're learning here. But let's go back to the CLI. There are some rules for the CLI. So if on my terminal, I type down Cardano CLI, I will see this here, usage Cardano CLI. And there's some rules here. The rules are if it's in parentheses, it's a mandatory option or parameter. If it's in square brackets, it's optional. But if you need it, you can use it. If there's nothing, it's mandatory. And the separator here, the little bar that you see, it means or. So if I try to read that, I see Cardano CLI. So the subcommand that I can use is either address or key or node or hash or query or legacy or well, you get it, right? So with that line of thought, if I go back and I want to generate a key, that's a Cardinal CLI Conway because we're on Conway era. So every single command we're going to do is always on Conway.
Okay.
The CLI allow you to use every other era if you want to because it's mostly for testing. So people, they usually, sometimes they spin up local clusters and they want to test something, but they have to use it from the Shelley era or another era. You can play with it a lot, right? But for everything we do, it's mostly Conway because it's related to governance and it's the latest era. That's where we're at right now on mainnet.
Okay. How do I know what era we're in?
There's colors. So
Okay.
everything in green is Byron, everything in blue is Shelley, and everything in red is Conway.
Okay.
So we're going to be
So,
using the right side of this infographic mostly because you can see there are Conway address commands, but on the Shelley side, there is also the address command.
uh-huh. Yeah.
They're very
Understand.
similar. Yeah,
Yeah,
they're
very
very
similar, but with
right.
different. Yeah.
We want to use the latest. So it's
Mm.
always Conway. And we want to generate keys. But right now on my terminal, I'm seeing like Cardinal CLI because that's all I wrote. And I'm seeing like the options that I got, which are the main titles of all, like what you see here. Address, key, node, the query command, and there's all the subcommands that comes with it and the parameters of each subcommands. So it's like a command line tree in a way.
Yeah.
Okay. So if I want to create keys and I want to move forward with this, then I would have to do Cardinal CLI Conway address keygen. And then I would have options that are written here. So let's go ahead with Cardinal CLI Conway address keygen. Oh, there's a little thing there. And as you can see, if I make it a little bit smaller, you see here, you get the same options that you have here. But they're all square brackets. Everything above is optional. You can have your key output in BEC32 and text envelope and different formats, but it's optional. I want to keep it simple. I want to generate keys. And these two here, they don't have no brackets. They don't have nothing. So it's mandatory. So you have to use these two parameters and you have to define the
Right.
name of
That's
the name of your file pretty much. So what I'm going to do that again. Cardinal CLI keygen command, and then I will break the line to make it pretty, and I will do verification key file. My verification key file is my verification key. That's the public key. So I will call it payment.vkey. Okay. You can give it the name that you want, but that's the naming convention. So that's why I'm following this name. The extension is usually V key for verification key or S key for signing key. Okay, so I will break the line and I will need to mention my signing key file, which I will call payment.skey with the extension signing key. Then I press enter. And now I have a verification key and a signing key. Cool.
Cool.
Technically, I could create an address from the verification key because your address is always derived from your verification key, a Cardano address. But if I do that, I will not be able to interact with the staking protocol because I need staking keys. The command is the same. You need to generate stake keys. And since on my tutorial, I do have an easy little copy pastable command, I will use this one instead of just writing it down. It's the same one. So let's just copy paste. As you can see, Cardano CLI Conway stake address. Oh, it's stake address. I'm sorry. Keygen. I'm generating a stake verification key and a stake signing key. The same way. Enter. So now I have two key pairs, the stake key pair and the payment key pair. What does each set of keys control? The payment key pairs, they control the money that you have in your wallet. So they are the keys that you use to spend your UTXO that lives in your address. We'll get there soon. Within your wallet address, when somebody sends you money, you have UTXOs that only your private key can unlock in order to spend it. Okay? So the payment keys are made for that. The payment keys control the money that's in your wallet. And the stake keys control the delegation and the reward. Delegations and the reward. So when you're delegating to a stake pool operator, when you're delegating to a DREP, or when you want to withdraw your reward from the staking protocol, from your stake address, which is account base, you will need to sign the transaction with the stake signing key. But if you just want to send money to Kineric because he's threatening you uh, of not giving him enough money or not
That's
staking to his
happened,
stake pool, uh, then you would need to sign with the payment key. There's some cool stuff you can do with that. But it's important to understand the difference between those two keys because you can mix them differently if you wanted to. But I'll get there.
So just to repeat and make sure that I got this right, the payment key pair controls the payments and the payment sending and receiving of the money in your wallet.
Not receiving. No,
Not receiving.
No, you can't
Only
stop
the
somebody
sending.
from sending you money.
Okay.
Yeah, it's something you can't block.
But anyway, I'll notice that for when I talk to Henrik later on. And the stake key, that key pair controls the staking rewards and also the DREP presentation if you want to give your vote to a
Yes.
DREP. Okay.
All delegations, it controls the withdrawal of your reward from the staking protocol. Yes. So you need those keys. But we created those two key pairs independently. So if I stake with these keys, the ledger doesn't know the owner of those stake keys are the same than the owner of those payment keys. So you need to link those two somehow. And you do that by creating an address that is derived from both your stake verification key and your payment verification key.
How do you do that?
with the CLI.
Payment key.
You might want to explain what you mean by derive.
What do I mean by derive?
Yeah, you said that we have to connect stake key and payment key together,
Yes.
and
Yes.
we do that by
Oh,
generating.
yeah. So it's by hashing the verification key of the stake key, and also the payment key, the verification key of the payment side, by hashing them and by converting them into a bec32 format that the blockchain would understand, in order to use this address as a way to verify that also you're the owner of the private key part of those two key pairs. I'm going to give you an example.
Thank you.
Cardano CLI Conway address build here is a command that you can use to build an address. But as you can
Oh,
see, as I mentioned before, what is required in parentheses is that you provide at least the verification key file of your payment keys. So if I wanted to, I could just generate an address from the payment key. But if you send money to that address, there's absolutely no way for you with that address, with that wallet address, to interact with the staking protocol, because you cannot stake that money, because it's in an address that has been generated from only the payment key. It's shorter. We'll try it. I'll show it to you. Cardinal CLI.
And Cathy, and here, Cathy, this is the beauty with SHA-256, the hashing mechanism. When you see it in the blockchain, you will see it a lot going through. It's
okay.
basically like when you have a hash. I think Mike told you earlier that when you have a hash, that is unique,
Yes.
totally unique that represent a value, and you cannot guess what the value is, but you can look it up and verify that it is.
Okay.
Okay. Let's just put it this way, because I don't want it. I don't want to save that into a file. So if I generate an address from only the payment key, I get this. I get this address. So it hashes the key and it converts them in a bec32 format that the blockchain would understand, that it could then use in order to, because the transaction in a way, I don't want to phrase it like that because that's not entirely right, but the transaction in a way is like a challenge string that's sent to you. And when you sign it, you confirm that you are the owner of that address, because within that address has been derived from your verification key. So you can, well, you can see in a way this address as the challenge string, right? But it's not technically that. That's not a good example. But it's a way for the blockchain to understand who is the owner of the private key of that payment key pair.
Okay. And that
Okay.
address
Think
that.
of
I can send money to that
so,
address, but I cannot stake from that wallet.
Okay. Because those two are not
so
connected.
Yes, in this
You haven't.
address, you only have the hash of the verification key from the payment
Yeah.
side. But if I do that again, but this time I use also the payment key, sorry, the stake key here. Same command, as you can see, but I use the payment verification key and I also use the stake verification key.
Okay. I'm building kind of images in my head. When I learn these kinds of things, I have big trouble with visualization of code, and that's why I was never a good programmer. However, I managed my way through school and through my education and through my work by uh, drawing pictures to myself. So this is like an address to a money box. It's to a wallet. It's a box of money. You can put money in that box because you have the address, like housing. You know, you have several houses, different address, so you can put money in them. But you cannot stake because that's a totally different address. It's like a street on the backside
Yes.
where you stake from. So you have two streets. On the front side, you put money in, and on the back side, you stake. Feel free
It,
to
And,
draw
and,
those
and
pictures.
no, no, no. It's
yeah, and to give you a cool picture here, Kathy. So let's take the stake address. Just imagine that is the main entrance key, to put it like that, and that key that the stake address that you generated with your keys is that is to unlock that door. But to get a wallet address, which Mike is making now, you need like when you have a house and you can use the same key for many doors. So
yeah,
basically what you're doing here is
Making
making
a
a
system
key
key.
to the
Yeah.
next, you're making a key to unlock your next door in the house.
yes.
And you
I like
have,
the
Okay,
example.
I get
That's
it.
a
I
great
get it.
example.
Yeah, that's a good example.
Yes, the private key is your house key, and the verification key is the lock of your house. Everyone can know your house address. It can be derived, it can be freely shared. You can share that lock to anyone. You can share your address to anyone. Nobody can get in unless they have their house key, but you are the owner of that house key. And the address is derived from the lock. You get that address from the lock in our scenario. But
Yeah, okay, yeah, I get it.
and in this scenario here, we have a stake key pair and a payment key pair. So it would be like as if your door had two locks on it. To get in, you need both keys to unlock your door. Um,
So this command is to link both the stake key and the payment key
and the
together.
payment key to let the ledger know that both key pairs belong to you.
Mm.
But we'll get there soon. If I do that, I generate an address that looks very similar to this one. If you look at this hash here, you will see here that it looks
Yeah,
very similar.
same, but it's wrapped in. It has the wrapping in front and in the back.
Yeah, but this one is longer because it contains also the hash and the information of your stake verification key. If
Yeah.
I send money to that address, then you can use the money that's in it for the staking protocol. Because whatever the amount of money that you have in that wallet, the blockchain can also understand it for delegating to stake pools and DREPs. So it will use the amount of money that's in it as voting power or as uh, stake to help that
Mm.
stake pool produce blocks. Okay, so now we have a longer address. We generated them, we generated it from the verification key and the payment key. Okay, that's like the molecular level of a wallet address because technically, technically, you could have many wallets that uses the same verification key for the address. So you can generate more payment keys, but you create the address from it with the same stake key, but there are different wallets. So you can have different wallets with different amount of money in it that is linked to the same stake key. And we call that Franken wallet.
Fra what?
Franken. Franken wallets.
Frankenstein. Just think of Frankenstein.
That's literally the
Yeah,
name.
I was like, did I hear that right?
Yes. It's just
Franken
I don't want to get
wallet.
too deep because there's so many cool stuff you can do with that. You
Okay.
can I don't want to get there because I feel like I'm going to lose you. So I'll just stay with the basis and then we could go further as we move forward. Let's keep it simple.
I'm
Okay?
just noting that and writing check out.
Franken
And
wallet.
then
Yes.
check it out
Sure.
later.
So right now I'll just create a payment address that we can see here from the command I showed you. That's here. To create an address. So it's literally the address in a file, right? So if I just cat the payment.addr, I will get the address.
Cool.
But right now there's no money in it. It's a it's a test address because that's on testnet, right? Because when you create an address, you need to mention the network. As you can see here, the address build command, it's required to provide the network. But for me, the reason why I didn't have to put it is because they're already set in my environment variable. So I don't have to write them down every time.
But
My
I can try this on CentralNet, right?
Yes,
Great.
absolutely. I can send you some money on Centranet. Yes. Um,
You were gonna be sons rich, Kathy.
yes. Some of the people from the community like to call it central bucks.
I have a nice smile, you know, Kennedy. Well, always good to smile. Spread some sunshine into the world.
Uh, okay. So as you know, in the UTXO model, every time I send you money, I create a new UTXO. And by UTXO, I mean unspent transaction output. Okay. So let's say you have $20 in your pocket. I like that example. You have $20 in your pocket and you want to give me $3. You can't technically tear that $20 bill apart and give me just 1/4 of it, right? You need to do some change. So you have to spend the entirety of the $20 bill and then you give me $3 and you get the change. But the original $20 is not there anymore, right? The $20 bill. Uh, was that complicated? The reason why I say that is because you cannot. Okay, I'll show it to you. I'll show it to you. Um, yeah, this is a hard concept. UTXO, unspent transaction output, and
Unspent
unspent. So I'll use my nice little paint.
output. UTXL is outspend
Unspent,
unspent
unspent
transaction
transaction output.
output. Okay.
Output. So we have a square here. That is the
You need to
transaction.
share your screen.
Oh
No,
shoot.
it's shared.
Is
It's
it?
shared.
Yeah,
I
it
Oh,
can
is.
see the paint square.
Yeah, it's
oh,
just
sorry, my bad.
yeah, it's just an ugly square that represents the transaction. And we have no, I'm not going to write Katie. So we have a wallet here. Let's do a wallet there. And within this wallet, there's UTXOs that I will get there later. In this UTXO, we have 5 ADA. Oh my God, that's not good. No, I'm not good with paint. That's terrible. I need to have one of those things like Charles Hoskinson where I can do a drawing with
Yeah,
my.
haven't you gotten this nice tablet? You know.
Yeah, I need to do that. I used to be able to do it on. I think there was a tool on. Was I able to do that on the screen share of Google? I think.
Yeah,
Uh,
you can. You can.
anyway,
But
let's go back to this. Okay, so let's say I have $5 in this UTXO, I have 6 in this one, and I have 10 in this one. Okay, I want to send to Kathy, I want to send $15. I don't have $15 in a single UTXO. So I would need to spend two of them, right? This one and this one. So they are transaction input. And here we have the transaction output. I'm sending to Kathy 15. There you
Thank you.
go. That's a weird example. If that was like this, it would be super easy. But let's say I want to send you $14. Okay. I would still need to spend that UTXO and this one, but I'm providing $15. So I'm going to give you 14 as a transaction output, 14 to Kathy. And I have an unspent transaction output left that is 1 ADA, or actually it's not 1 ADA, it's less than that because I have the transaction fee to pay to the blockchain
yeah,
protocol.
for the record, for the record,
Yeah, for the record.
simplicity.
Yes. So I created two UTXOs and I've spent two UTXOs. And this is the way it works. It's not like the accounting model. You can't just grab uh, four, four ADA from this UTXO and spend it without spending the entire UTXO. So every time you spend a UTXO, you need to spend all the money that's in it. And then at the end of the transaction, you get the change. But every time you do a transaction, you need to spend the entirety of the UTXO that you need for the transaction. So I'll make a worse example.
So what happens to the one that's left when you're done with the transaction? It comes back, it goes back in.
Yes, it's a transaction
Okay.
output that is directed back to your wallet. So it's like you're spending transactions, you send the money to someone, but you have an output that goes back to your wallet as the change.
Okay. Okay.
Yes, that's the way it works. Um, I'm going to give you an example. So in an address, you can have as many UTXOs as you want. So as a matter of fact, every time somebody sends you money, it doesn't mix up with the UTXO that you already have. It just creates a new one every time. And right now, if I do
So it doesn't the UTXL doesn't expand. It just creates another one
another
in
one,
your.
another one, another one,
Okay.
and when you spend them, you just spend them. You just spend those UTXO depending on how much money you're sending, and if there's money left, then it creates a new UTXO into your wallet with the new amount of which represent the change. Uh,
So this will represent a file storage. Um, does it have any limits but how many UTXL you can have in a wallet?
no,
Okay.
well, the limit is your memory.
Exactly. Exactly. My point.
The memory of all the nodes of the network. And right now, that's why the minimum requirement for mainnet is 24 gigs. I think that's what it is still, but a nice 32 gigs is enough. We have over 4 million wallets, and there's a lot of UTXOs, and they all live in memory.
Obviously, lots of
So I,
UTXL.
I I usually say like this. So every transaction has an has one input and always have a bare minimum two outputs, and all those outputs, those are outputs that one of those are one that you control with your wallet. And every UTX output is unique. And that's how the ledger is so secure and keep track of
Yeah.
every output on the ledger.
Yes.
Um,
And
and
only
whatever's left over goes back to the original wallet as an unspent transaction. So this is like
yep.
change.
But it's in the form of a new UTXO. So every time you have to spend it, and the ledger knows from that address, for example, that only the owner of the private key of that address has the ability to spend the UTXO that's inside it. So if I use this address that I have now and I query the UTXO that I have in it, so it's a query command, Cardano CLI, conway query. I want to know my UTXO from the address, which is the content of my payment.addr file. I'll make it quick, but that's also showed in the infographic. I will get UTXOs, but it's complicated like this. So I will do an output text for the example. There. In this address, I have 3 UTXO, and they all have a different amount of money. And it's in Loveless. So one ADA is 1 million Loveless. So if I want to know how much money I got in this one, I remove 6 digits. So this one has 4,659,199 ADA.
Damn, you are a one rich man.
On Centronet, I'm super powerful. But it's monopoly money, right? That's
Of
not
course.
my realm. But anyway, if I want to send you $15, 15 ADA from that UTXO, I will need to spend it all. I will need to spend the entirety of it, give you 10, and the entire change will go back to my address
But in a new UTX,
in a new
UTX,
UTXO. Exactly.
yeah.
Which
So this
means,
UTXO will be gone. You spent all of that, and
yes,
then you get the rest, but it's in a new. The total amount without the 15
yes.
is that in new UTXO. Okay.
So if I want to interact with the blockchain without sending money to anyone, for example, I want to register a stake address, for example. That's something we will do later. I want to register a stake pool. I want to be a DREP. I'm not sending money to somebody. I just want to interact with the blockchain. Then I would have to spend the UTXO for the transaction as a transaction input, and I have one transaction output, which is my own wallet. So I'm sending the change back to my wallet, one input, one output. But in the transaction, I can include data
Instead of money. Yeah.
instead of money. Well, I do have to pay for the fees of the
Mm.
transaction itself, but I'm just spending the transactions to do that. I'm spending the UTXO to pay for the fee, and the rest goes back to my wallet, and I do things like interacting with a smart contract, registering a stake pool, registering a stake address, registering myself as a DREP. Uh, I interact with the blockchain, but I
Yeah, and
don't
that's
send
why
money to someone.
can I that's what happened this the other day when we created the wallet, and I put my
Yep.
votes into a DREP, and you saw that
Yeah.
the transaction fees goes.
It's a
So
little bit more
Yes,
that happens, but basically, Mike is spot on there as always.
yeah,
everything that happens there, all those UTXOs that you see there, they are public information. This information is in every single node on the planet. And with your address, if you give me your address, so if I say on mainnet, give me your address, I can see exactly how much money you have. I can see exactly what UTXO you have on your wallet from my own node, but I don't have access to it because I don't have your signing key.
Transparency.
Yes,
It's beautiful.
but also there's no correlation between a wallet address and its owner, right? So
Mm,
I can't tell that this address is Kathy's wallet
of course.
unless you tell me it's yours, right? So
Yeah.
it's public, but at the same time, there's some privacy within the blockchain. So you don't have to KYC yourself when you create an address. You just need to generate those keys and you have an address. No more requirement than that. Um, I was going to send myself some money, but I realized we don't have much time. So we could move forward with that. There's a lot to say about this, and it's the groundwork for everything we're going to do in the future, and you will get used to that so much that it will become boring because every single time you do something with the blockchain, you always build a transaction, sign it, submit it. Build a transaction, sign it, submit it. Create something, you create a registration certificate, build a transaction, sign it, submit it. And every time there's transaction inputs and outputs, depending on what you want to do. But the beauty of this is that within a single transaction, you can send money to thousands of people at once because you can set the numbers of outputs that you want. I can send 10 to Canaric, 10 to you, to countless people as long as the.
Okay.
Yes,
So you can only use one transaction, but you can, with one transaction, you can send to several.
yes.
It's not a one-to-one
You
logic in this.
no, you
It's
can
like
send
you
to
can
se.
just use one transaction and you can send to several wallets.
Yep. And for some cases, you can send to severals, but you can also have many inputs from different wallets if you wanted to. You can
That's
nest.
interesting.
Yeah,
That's cool because then you can save both the traffic and the fees and yeah,
mostly the fees, but most of the
most of the
people
fees.
they don't do that because well, for trusting issues and things like that. But if you know how to read a transaction because it's public, some people does it. For example, multi-signature wallets, um, but it's not necessarily related to multi-signature wallet. So I could build a transaction and get money from your wallet and my wallet at the same time within the same transaction and send it to several, but I would need the signatures or the witness for every wallet involved because I cannot interact with your wallet or spend money from your wallet unless you provide also the witness from your signing key. So you would have to sign the transaction that I build. But yes, we would save some money on the fees, but nobody does that, right? Uh, but it's possible. It is possible. You can do that. Well, as a matter of fact, I have many wallets. So if you have many wallets that you own yourself, you can spend them all in the same transaction to do different things all together. Oh, I'm gonna stop sharing my screen. I gotta go pick up the kids. But if you want to, we can talk more about this next time on Thursday.
Absolutely. It's very
What do you guys think?
interesting.
But what is actually very cool now, Kathy, the thing here, generating wallet, generating stake address, make a debit, receiver address, and actually understand how the UTXO model works. If you understand that, you have 100% trust in the blockchain technology. Undeniable. It's
Yes.
like and this is knowledge that 99.99% of the world have absolute no clue of. They just say, "Oh, it's blockchain. Okay, then it's secure. Okay, I spend $10,000 on this because I think it's secure." But they don't know what actually, if it is secure or how it
Yes.
actually works.
And how
So
it's
this is
secure. Because
I
how
yeah,
how
yeah.
do you
yes.
know,
I
right?
didn't
Because also you have transparency. So how does that work together. Transparency and security is usually not two things you hear in the same sentence. So it's very, very nice to know how this works in the background.
We have all the same data. What I showed you, everyone has it, but the thing that's mostly beautiful about UTXO model is that I didn't have time to show it to you today, but I'll show it to you Thursday if you want to. You know the finality of your transaction before you submit it, and I will show you exactly how. But Thursday, because I didn't have time to tell you that all your outputs have the same UTXO hash than the transaction ID itself. And depending on the order of outputs you have, they all get an index number that has the same transaction hash. So your UTXO is the hash of the transaction ID that's been used to create it, and the index number is your order in the outputs. So if I send money to you, you get the index 0, and the change back to me get the index 1. But I'll I'll show it to you next time. And this is why it's strong, because we know the finality of the transaction before I even submit it on chain, which means that I can build it offline, which also means that I can build every action that's coming after before. So I could pre-build thousands of transactions in advance by just chaining them together like this.
Mm.
And
And the
that's
cool
how
thing,
you
like
do.
when, oh, sorry,
Sorry. No, just
no,
go.
no, and you said like transparency, and security usually don't come good together. Well, there is one environment when you need one, let's say, component more, and that is encryption. So blockchain technology is using encryption that have been tested for decades, many decades. Some of the research for the encryption that we use in the blockchain, it goes way back to the 60s, 70s in the Cold War, when we had issues trusting Russia.
We're
Yes,
still having
but
those issues.
um, I I have to leave. I'm sorry,
No
or else
problem.
my kid's gonna wait for me in front of the school. But I'll
Thank,
I'll, I'll see you next Thursday, and then
Mm,
we can move forward with this.
perfect. Thank
All
you
right.
so much, Brett.
Thanks for
excellent
coming.
job, Mike, as always.
Have a good one.
Bye.
Bye.